Okay, so what if the next massive leap in AI has nothing to do with bigger, faster computers, but everything to do with biology? Let's dive into this really wild new way of thinking about AI, one that actually borrows its design from life itself. Just think about that for a second. What if the key to making AI smarter isn't buried in some super complex code, but it's already running inside of us? The whole idea is that we could build the chatbots and creative AI we use every day by basically copying the biology that makes us tick. So let's really get into this. How exactly do you build an AI using an instruction manual taken straight from our own cells? The big picture here is that we're taking a system that nature has perfected over billions of years, and we're applying its core logic to our tech. Now, to really see how that's even possible, we first need to take a quick look at the biology part of the story. And that brings us to a concept with a pretty serious name, the central dogma of biology. But listen, don't let the name throw you off. It sounds complicated, I know, but it actually describes a process that's, well, surprisingly elegant and simple. At its core, the central dogma is really just life's recipe. It's a simple three-step flow of information that turns the master blueprint, that's our DNA, into these tiny functional machines called proteins that do pretty much all the work inside our bodies. Think of it like you're in a kitchen. You've got your DNA, which is this giant master cookbook with every single recipe you could ever imagine. Now, you don't want to bring that whole thing to the messy counter, right? So you copy just one recipe onto a little note card. That's the RNA. Then you use that note card to bake the cake. And the cake itself is the protein, the finished product that actually does something. So the information always flows in one direction, DNA to RNA to protein. So how in the world does this biological recipe help us build an AI factory? Well, let's map that exact same three-step process directly onto how one of these big language models actually works. The parallel here is it's incredible. So just like RNA is that temporary copy of instructions, your prompt to an AI, when you type, "Write me a poem," gets turned into a temporary code. That code is called an embedding. You can just think of it as a special mathematical translation of your request that the computer can actually understand. Okay, next up is the AI's version of DNA, that master cookbook. This is the processing stage. It has a technical name, latent representation, but honestly, just think of it as the AI's brain. It takes your coded request and it thinks about it, using a ton of math to figure out what's important. So, you ask for a poem about stars, and this is the part that zeroes in on concepts like night, sky, and twinkle. And finally, you get to the protein stage, the output. The AI actually writes your poem. But here's what's so cool about this particular model. It has a built-in quality control step. The AI can literally check its own work, kind of like a chef tasting the soup before they send it out. If a line doesn't quite work or a sentence feels off, it can tweak it right on the spot. Now, this all sounds really neat, but you're probably asking, so what? Why go through all this trouble to copy biology? Well, the answer is all about making AI way more powerful and flexible. The huge win here is that you get a modular system. Since each of these stages works on its own, you can upgrade one piece, say improve how the AI understands your questions, without having to trash the whole system and start over. That separation makes the AI incredibly adaptable, letting it learn from its own mistakes and switch between totally different jobs, like going from writing code one minute to composing a poem the next. And here's a perfect example of that in action. With this kind of design, we could literally just swap out the part that understands text and plug in a new one that understands pictures or even music. And the AI's core brain doesn't have to change at all. It just gets a new kind of instruction to work with. That is a massive advantage. Of course, we have to be realistic. This is still a very new idea. It's not the standard way people are building AI today. And there are definitely some big hurdles to get over before a design like this could really go mainstream. So on the one hand, yeah, a model this complex needs a ton of computing power, and the training process is really careful and tricky. But on the other hand, the dream is just so compelling. We're talking about the potential for AIs that are way more creative and adaptable. AIs that could one day work with text, video, and audio all at once. And maybe, just maybe, AIs that understand us a little bit better. So it really leaves us with this one fascinating question to chew on. By borrowing a blueprint from a process as fundamental and elegant as life itself, could we actually be on the path to building an AI that doesn't just compute, but creates and understands in a way that feels, well, a little more human?